All right, here we go. Lesson 5-7, we're doing more factoring. We are gonna be awesome factoring mathematicians. This time we're using ax squared plus bx plus c, where c is positive. So right there it says c is positive. So see this c right here? That has to be positive. Our essential question today is, can you factor trinomials whose coefficient is 1? So hopefully you remember what a coefficient is. They're saying that this number, instead of being a number, is just 1. Now, we would never write 1, we would never show 1, but the number's 1 because it's not there. And it continues to say, and constant term is positive, meaning this c term right here is positive. So let's review a little. The first thing we learned was the GCF. If my question is negative 3x squared y minus 12xy squared, I can take out a negative 3. Oh, I can take out an x and a y. And what do I have left over? When I take a negative 3xy out of negative 3x squared y, I just have an x left over. When I take a negative 3 from a negative 12, I have a positive 4 left over. And xy out of xy squared, I just have a y. Now, we've also talked about the difference of two squares. I'm not going to do all of these. Let's just look at b and c here. Okay, b is x squared y squared, a perfect square. It is. Xy is 121 a perfect square. 11. Anytime I have a difference of two perfect squares, I need a what and a what? Good, I need a plus and a minus. I'm going to put an xy in the front of each and an 11 in the back of each. The next one is x to the fourth a perfect square. It is. X squared. Is 9 a perfect square? It is. But because of this plus and knowing what we know on the pink sheet, remember that this is going to be prime. All right, the last thing we did was squares of binomials, and these end up being trinomials. And this one, for some reason, you guys always end up forgetting, but we're not going to forget it this time. Is 4x squared a perfect square? Yes. 2x. Is 25 a perfect square? Yes. 5. When I multiply these and double it, 2x times 5 is 10x. If I double it, I do get 20x. So I know that this is a perfect square with 2x and 5. And because of this sign right here, it is going to be negative. Now remember, when we check this, that's the answer. This is the answer. But when we check this, we do have to FOIL. And that's where the outers and inners become that negative 20. So just make sure when you FOIL this, you multiply it out correctly. Now, we're working with another type of trinomial where c is positive. So let's go ahead and look at the foiling of x plus 3 times x plus 5. When I FOIL that, I get x squared plus 8x plus 15. Notice that this is the sum of 3 and 5. Well, remember 3 and 5 are my numbers right here. And then notice that the last number, that constant term, that c, is the product of 3 and 5. Let's look at one more. X minus 4, x minus 6. My numbers are 4 and 6. When I add those together, I get that middle term. When I multiply them together, I get that constant, because we are foiling first, outer, inner, last. So now we're going to get this, and we're going to go backward. So we're given the trinomial, and they're telling us to factor, and they're saying, hey, if it's not factorable, write prime. So the first thing that we want to look at are the factors of 28. Well, we know how to write out the factors of 28, 1 and 28, 2 and 14, 3 doesn't go into it, 4 and 7, 5 doesn't go into it, 6. All right, we're back around. Are there factors of 28 that add up to be 16? Yeah, I see them too. 2 and 14. 2 times 14 is 28. 2 plus 14 is 16. So I know I can write this as x plus 2 times x plus 14. Again, let's check that in our head if I FOIL. First terms, x squared. Outer terms, 14x. Inner terms, 2x. Ooh, those add up to be 16x. Last terms, 28. A couple more. Are there factors of 8 that add up to be negative 9? Well, I like to write my factors out. The factors of 8 are 1 and 9, 2 and 4. Do either of these, I just said 1 and 9, didn't I? That should be 1 and 8. 1 and 8. Do either of these add up to be negative 9? Well, 1 and 8 add to be 9. How do I make them negative 9? Negative 1 and negative 8. So, y minus 1 times y minus 8. Let's check. First terms, y squared. Outers, negative 8y. Inners, negative 1y. Those do add up to be that negative 9y. Last terms, positive 8. One more. Let's see how we do. Are there factors of 20 that add up to be 9? You probably already know this. 4 times 5. So this is going to be k plus 4 in parentheses times k plus 5 in parentheses. Great job. Be confident when you see one that doesn't work. You're going to write the word prime. And you know what? Let's go ahead and do one more because I think this one actually is prime. Let's talk about the factors of 42. Factors of 42. 2 and 21. Oh, I forgot 1 and 42. Okay, do any of these factors add up to be 17? Let's see. Does 3 go into it? 3 and 14. Oh, those add up to be 17. Never mind, we don't have a prime yet. I thought we did. To make it a negative 17, I get a negative 3 and a negative 14. So we get p minus 3, p minus 14. All right, great job.